Good morning. My name is Javier Perez. I will talk about physicochemical and energetic characterization of solid biofuels for carpentry sawdust of timber species from Tabasco, Mexico. As an introduction to bioenergy, the intensive use of energy based on the burning of solid fuels such as oil, coal, and gas has been one of the main inputs to economic growth for several decades. However, global CO2 emissions from the use of these fuels have increased significantly in the last decade. In response to this situation, the search for energy sources to reduce greenhouse gas emissions has been promoted. One of these alternatives is bioenergy, which is obtained from biomass. It is produced from organic materials. The biofuels that can be obtained from biomass include solid biofuels, which are produced from a physical treatment of the biomass. By using solid biofuels, CO2 emissions are considerably reduced since the biomass has already captured CO2 during its development and growth, so that during its combustion an equivalent amount is emitted to that capture. So, in this context, the aim of this work has the physicochemical and energetic characterization of wood residues and solid biofuels of local species as a potential alternative to reduce firewood consumption as well as its implementation in gasifying and combustion ecotechnologies. In the methodology for the elaboration of biofuels as a first stage, three different wood shaving samples were collected: Cedrela odorata, Tabebuia rosea, and a mixture of both. Wood shavings from Pinus caribaea was used as a reference. As a second stage, the particle size was reduced to less than 4 millimeters with the help of an electric mill. In the third stage, called formulation, the sample was prepared by adding water until reaching 25% moisture content by weight, then 8% by weight of vegetable oil was added as a binding agent. In the stage 4, the previously prepared material was pelletized in a pelletizer model AF120. And once the pellets were obtained, they were cooled for storage. The physicochemical characterization carried out was proximate analysis, energetic properties, bulk density, friability, thermal analysis, and an elemental analysis. An analysis of variance between the calorific value of Cedrela odorata sawdust, Tabibia rosea sawdust, Pinucarera bahia sawdust, and mixed sawdust pellets was performed at a significance level of 5%. In the analysis of variance for the calorific value, it can be observed that according to the p-value, significant differences were detected between the calorific value of the pellets evaluated. In the table of results, we can observe that the sawdust present low moisture and ash contents and a high calorific value, which are within the established in the ISO 17225 standard, which makes it attractive to be used as biofuel. The pellets obtained present an increase in the calorific value with respect to sawdust, which is greater than that established by the aforementioned standard. so that the four types of pellets are classified as A1, which means that can be used for residential or commercial applications. And they also have a high percentage of friability, which favors their storage, transporting, and handling. According to Tukey test, Cedrela odorata, Tabibia rosea, and mixture are not different, so there is no need to classify the waste generated in the carpentry. The thermogravimetric analysis presents a comparison of the sawdust from the mixture of species and pine with the pellets obtained. The pellets of both materials contain a lower percentage of moisture than the sawdust, which favors their combustion. The greatest degradation of volatile matter is found in the range of 250 centigrade to 400 centigrade. It shows typical behavior of a lignocellulosic material in both cases, and all showed similar behavior before and after pelletization. In the elemental analysis, there is an increase in carbon and hydrogen and no sulfur and low content of nitrogen content, which is an advantage in emissions for biofuels. In conclusion, wood residues from local species of furniture, carpentry cooperatives showed attractive properties as a raw material for solid biofuel production, which may contribute to offering alternatives to face energy poverty and to migrate to an energy democratization in the southeast of Mexico.